Welcome everyone. My name is Sagar and we are back here with another video. So today's day 198 of our POTD series and today this question name is next greater element and this is given a medium level question. So if you have been following our POTD series then you know that we already did that question. So I think that question name was next smallest element or previous smallest element. So it was a very similar question and all the concept of the question is exact same. So we already did that question in our POTD series, and if you are following our series and you still don't still you can do that question, so you have to check yourself. You must have done this question, so it is a very easy level. So first of all, what we are given, so we are given an array of size n which have distinct elements, and our task is to find the greater element, next greater element for each element of the array in order of their appearance in the array. So first of all, what we have to do, so we have to just traverse in the array, and we just have to find the next greater element. So for 1 which is the next greater element, it is here 3, and for 3 which is the next greater one, so it is here 4, and for 2 it is also here 4. And it is obvious that for our value 4 there is no next greater element, so we have to return here -1. So what is your brute force approach? So first of all, brute force approach is you will check for all the elements from 0 to last second, because we know last element don't have any next greater element. So first of all, let me also create this long array. So this is your brute force approach, right? That is also of size n, and we also know that for our last element, that means for our n-1 index, we don't have any answer, so we will fill -1. And after that, for every element, what you will do, so for 1, so you will just run another loop that will traverse in all the next values. So what you will do, for you will just run another loop that will start from I+1 and j should be also less than n. And what you will do, if ARR's jth element is greater than ith element, then you will just say answer of I equal to j, and you will just break here, break. So we will then check for next element. So suppose for R1, so let me just write it here. So suppose we have 1, 3, 2, 4. So this is our first element, and we will just run another loop from this range. And when we are at 3, so we will see 3 is greater than 1. So we will just store our 3 as the answer for this value. So 3, this is our answer array, alright. And last element have -1 value. So 3 is the answer, and after that I will just move ahead. So I will be here then, and we will start another loop for this range, and we will get 4 as our answer. So here 4, and here also 4. And this is our brute force approach. Time complexity is here, you can see n square, and at last you will return answer. So we have to optimize it now, and you know that thing. This is a very easy question. What we have to do, let me just explain the approach. So we have to do this question in of n time. So this is a valid approach, but the time complexity is high here. Time complexity is n square. So first of all, we have to do it in of n time. So this is accepted, right? And now we have to optimize this. So how you can, so first of all, see that approach. You have to observe something, that we have to always start from last element. Because why? Because we know that last element don't have any next greater element. So we know for our last element answer will be -1, and we will store it somewhere that this is the greater element, right? And that this is the greater element. If there is any possibility, then this will be the answer for the greater element, and if there is no any possibility, then we will just say -1. So let me just check. After that, we just stored this value somewhere, right? And after that, we have here 2. So for 2, what we have to check, we have to check the next greater element. Is there any possibility that 4 is greater? Yes, 4 can be greater, so we will just store here 4. And after that, we also have to store this 2. So along with 4, we also have to store this 2, that there can be possibility that 2 is the greater one, and there can be also possibility if 2 is not, then 4 can be the greater one. So I hope now you understand this thing that I'm saying. So now we just stored these two values, and after that we are at 3. So we will just say, is there any possibility that this element, the previously stored element, is the greater one? No, it is not. So what we will do, we will just remove it. So after that, we only stored this 4, and 2 is here. So we are only storing this 4, and after that we are checking, is there any possibility that the stored element is greater? Yes, there is. So we will just store this, and after that we are storing these two, that there can be a possibility 3 is greater, and after that 4. So you can just see we are what we are doing here, last in first out. So we just stored our 2, and first of all we are checking this, if 2 is greater, no, if it is not, then we are just removing it. So last in first out. So That means here we have to use a stack. So first of all, we will just store here in a stack. This is here 4 and this was here 2. And let me just show you. So whenever we are at 3. So when we are at 3, we will just this without top element. So top element definitely will be the next element. Okay. So top element will be definitely the next element and we will check if it is the greater one. No, it is not. Then we will remove it from the stack because if it is not greater than 3, so if 2 is not greater than 3, then it will definitely not take part in any answer, right? So if 2 is not greater than 3, so 3 will be obviously greater, and for our next element 3 will be the greater one element. I hope now you understand it. That is why we have to use here a stack. So 2 is not greater, so we will remove it, and after that we will check 4. Yes, 4 is greater, so we will store the answer here as 4, and after that we also have to store here 3 because for our next values 3 can be the greater one, right? And here it is. So 3 4 4 minus 1, that is our answer. So we have to use here simply a stack, and you can also see we are traversing from last, so we have to traverse from our last index. So I will just create here a stack. Let me just do this thing, stack of long values. So this is long wrapper class. Okay, you can also create here an array tag that have the same methods. So now what we have to do, so first of all we have to start traversing from our last index and the last second. So you can also traverse from last, but I will just show you how we can traverse from our last second index. So there is no answer currently, and we just stored here -1 for this value, and this value is already in our stack. So this 4 is already in our stack, and we have to now check for this 2. So we will start from n minus 2 greater than 0. So what we have to do, so every time, first of all, what we have to do, we have to check what is the next greater element. So we'll check in the stack that is this the greater element. If it is, then we will store the answer, and if it is not, then we will just remove it. So we have to remove until the stack is empty. So while not stack is empty and we have the smaller element. So if we have smaller element in our stack, then we have to remove it. Okay, there is no equal element because we have only distinct values, right? Here we have only distinct values. So if the stack element is smaller than our current element, lesser than current element, so what we are gonna do, we will just remove it from the stack. Like in this example, if we are checking for 3, 2 was already present and 2 is smaller than 3, so we will just remove 2, and after that 4 is our answer. Okay, so first of all we have here 4, and for 2 we will check if this is the greater element. If it is smaller, then we will remove it, and if it is not, then we will check if the stack is empty, then there is no answer. Answer of this I is equal to -1, then that means there is no next greater element. And if the stack is not empty in this case, like, so for 2 there is a greater element in the stack, and if the stack have any smaller element, we already removed it, so it is guarantee that in the stack we have only greater element, and that is obviously next greater element, immediate next. So we will just store the answer st.peak. If the stack is not empty, then we will just store the answer from our stack. And at last, we also have to add this number to our stack because it can be the next greater element for our further values. Okay. So I hope now you understand this approach. And we have to here push this current element. All right. And that is it. So this is our O of n approach. And we also have to add here stack dot last element. We have to also have to push here last element, and I think we don't have to do this will be also covered in our these cases. So first of all, initially stack will be empty, and we will just push the last element also, so we can just traverse from the last element, and we don't have to even do this and this. So the stack will be empty, and we will just store -1 for our last value for this 4 value. Okay, so this thing is also covered here. So the time complexity is now you can see O of n here, and space complexity O of n. So that's it for today, everyone. If you already did this question, then let me know in the comments that you are following our series and you already did this question. So I think there is also another approach for this question. Let me know in the comments what is it, and thank you for watching.